At the centre of our solar system lies the Sun, a massive ball of boiling gas spewing out enormous bursts of high-energy charged particles. These bursts of energy, or solar storms, are occasionally directed towards Earth, travelling at speeds of over 1,000 kilometres per second. Upon impacting the Earth's magnetic field, solar storms can have detrimental effects on power grids, high-frequency radio communication, satellites, avionics, mobile telephones, aircraft navigation and communication systems, and GPS. As society becomes more and more dependent on modern technology, we become increasingly vulnerable to the effects of space weather. The largest solar storm to impact Earth was the Carrington event in 1859, which knocked out the global telegraph communication system, creating widespread chaos. In 1989, a solar storm severely impacted the Hydro-Quebec power grid in Canada, leaving 6 million people without power for 9 hours. Other solar storms have led to satellite malfunctions, GPS errors, and radio blackouts. An extreme space weather event can have disastrous impacts, resulting in potential economic losses of over $1 trillion. Due to a growing awareness of the potential consequences of extreme space weather, governments in numerous countries now consider solar storms a risk to the world economy and society. The South African National Space Agency plays a key role in monitoring space weather and is part of the worldwide network of magnetic observatories. The facility in Hermanus is responsible for research, infrastructure and data used to monitor the near-Earth space environment. Local space science research enables South Africa to create its own space know-how, providing real solutions to everyday challenges.
SANSA has a facility dedicated to space science. What this entails is using infrastructure to monitor space from the ground. We contribute to many global programs through our data infrastructure and the fact that we can calibrate data from satellites as well. But that is not the only thing we do. We also utilize the data to create fundamental research know-how. So we look at everything between the Earth and the Sun. We look at the space environment, we look at plasma physics, we look at atmospheric physics, we look at magnetometry in order to be able to utilize this better for mankind. And those applications are used in our Space Weather Center, which we're extremely proud of. It's one of the only space weather centers in Africa. We also utilize our knowledge of the Earth's magnetic field and our unique facilities here in Hermanus, our magnetically clean environment, to develop magnetic technology products and solutions that you cannot get anywhere else in Africa.
The SANSA Space Weather Center provides an important service to the nation by monitoring the Sun and its activity, providing space weather forecasts, warnings and alerts to government and private industry users in Africa. Space weather products and services are required primarily for communication and navigation systems in the defence, aeronautics, navigation and communication sectors.
Space weather refers to the collection of processes beginning at the Sun and ultimately affecting the technology on Earth and in space, which has a direct impact on our daily lives. In order to protect people and systems that might be at risk from space weather effects, we need to understand the causes of space weather and ideally be able to preempt the consequences of space weather events by means of efficient warning and prediction systems. In the Space Weather Center, we monitor the Sun. We use the space weather models to predict when the impact is going to be on Earth, and then we estimate as well the arrival time, and then we will send out the warning messages to the people who will be affected by space weather events. The people who receive the space weather warning messages, they are able to look for alternative options that will not disrupt their technological systems.
Earth is surrounded by an invisible force field known as the geomagnetic field, which protects humans and other life forms from the harmful effects of space weather. Without this field, life on Earth would not exist. Building on over 80 years of monitoring the Earth's magnetic field, SANSA has developed unique capabilities and a wide range of state-of-the-art equipment to provide specialized magnetic technology-related services.
Working together with key role players in the space and aerospace industry, SANSA is responsible for the acquisition, calibration and evaluation of magnetic sensors to be integrated in dynamic platforms like satellites and unmanned aerial vehicles. Furthermore, we are also involved with determining the magnetic properties of dynamic platforms prior to integration. SANSA is also recognized as being a national expert in magnetic technology applications. The system behind me is a 3-axis Helmholtz coil system, and the system is used for the cancellation of the Earth's field and then also to generate any magnetic field that are available in space and on Earth. This is the only large operational coil system in Southern Africa, and it's used on a regular basis for the calibration of magnetic systems as well as systems containing magnetometers. The main purpose of that is to calibrate the sensor, but then also to calculate the magnetism of the platform and to compensate for that.
This is a non-magnetic temperature chamber that we use to simulate temperatures that equipment that go into space would experience. For example, a magnetometer that is used for orientation purposes on a satellite. If the satellite with a magnetometer is on the day side of the Earth, in between the Earth and the Sun, it may experience temperatures up to 80 degrees. If it's on the night side, away from the Sun, it may experience temperatures as low as -60 degrees. The non-magnetic temperature chamber can simulate temperatures from -60 all the way up to 80 degrees, and we can characterize the magnetic properties of magnetometers under the circumstances.
This is a non-magnetic screening chamber, and it basically consists out of many layers of high permeability material on the inside. The purpose of the high permeability material is to screen the Earth's magnetic field. Now, this chamber is used very often to determine the electronic offsets of magnetometers. This is a good example of a magnetometer, and it's used for navigation purposes on board satellites, unmanned aerial vehicles and smart bombs. Unfortunately, the electronic offsets of these magnetometers drift with time. So it's very important for clients or users of magnetometers to bring them to SANSA Hermanus for regular calibration.
This is a squid magnetometer. It's a very sensitive magnetometer. It is made from superconducting quantum interference devices that we call squids. They are manufactured from superconducting material that has no resistance at a very low temperature. In our case, we use this magnetometer to look for seismic activity, very faint signals that are associated with the precursors to earthquakes. There will be certain stations around the world all equipped with squid magnetometers, and triangulation of signals will happen in time to determine whether an earthquake is about to happen and where that will be. We hope that in a few years' time, the information that we get out of our squid system would be fed into an early warning system to predict earthquakes.
To protect the technology we depend on daily, we have to understand the environment it operates in, which is why it's critical to monitor our near-Earth space environment. The South African National Space Agency is constantly monitoring space weather and the Earth's magnetic field in order to provide our clients and the nation with cutting-edge space science services, information and training. Space weather and its impact on society is just another reminder of how fragile our blue planet is as it races around the sun.